today we'll focus more about your presentations for your group. But I have a question. I think one of you guys already sent an email to me. I don't remember which group. Everybody's okay with this group, or everybody's collaborating, or is there any problem?
No problems with the group so far, for me personally.
Okay. I mean, if there's something, don't be shy. Just let me know, and I'll try to fix. Okay, so maybe we can start by group number A. If they can start presenting, that would be great.
Yeah, we can start presenting.
Go ahead. That's A, right?
Yeah.
Go ahead.
Okay, can you hear me?
Mm-hmm.
Oh, okay, sweet. So our plan is to implement the RSA algorithm using the Nexus A7. So I'm Nicole, Christiana's sharing, and then I don't know if Darian and Andy are also here, but yeah.
I'm here.
Cool. So basically, just a quick background, why we kind of chose RSA, right? There's the RSA actually stands for basically the people that created the algorithm, right? So the last names Rivas, Shamir, and Adelman.
Mm-hmm.
And then so basically just as a whole, we're kind of interested in using this because it's used almost everywhere, like web browsers, emails, VPNs, and so it's very applicable in modern day. So pretty practical. So it just kind of makes it overall a good thing to study and get familiar with.
And this is our timeline about our task. So we have our start date, our end date. So this is our task that we wanted to do. We want to research the algorithm, research performance benchmark, and implement the algorithm, and implement the benchmark, as well as then make the video paper and presentation. And those are the dates on when we're planning to do them.
Mm-hmm.
And then we also put them in a Gantt chart format, so it's easier to see.
I appreciate it. Do you guys have any question for them? The question? Thank you. I appreciate it. Group B, please start. Group B.
Can you hear me?
Yes, I
Hang
hear
on,
you.
Professor, one moment.
Go ahead.
Are you able to see the screen?
Mm-hmm.
So our group is group B. We're going to be looking into some stuff with computer vision, looking at different object-oriented, analyzing different object detecting and classifying algorithms. This can be anything from the YOLO version 1 through 5, CNNs, RNNs. So we'll be taking a look at these different types of algorithms and compare them and try to quantify the efficiency of each of their architectures, and some of the stuff that we'll be doing through that, something like a amount of train time, their accuracy to images, how much cost of resources such as RAM usage, time spent, just different stuff like that. Look at their constraints, see how widely applicable they can be, and hopefully towards the end of the project, we'll be able to implement some sort of like webcam to be able to give a better representation of or better show the accuracy of each of these architectures from ones they
Mhm.
select.
And then this is just a Gantt chart. Obviously, we start planning and now we'll start doing the research after proposing things to do and designing, testing, and then we'll do report writing all while doing the design and testing. So we'll do that like hand in hand with each other. And then towards the end, we'll just revise everything, work on the video and the presentation and paper.
Good. Do you guys have any question for them? Thank you, thank you. I like it. Group
you.
C. Go ahead.
Give me 1 second.
Take your time.
Okay. Hello. We are Group C, and we will be evaluating the YOLO object detection algorithm. And for our group, we are Kyler Martinez, Ruben Gutierrez.
Which
Austin-
YOLO?
Sorry.
There are many YOLOs. Which one?
Yes. So we'll be looking at. We haven't decided exactly which one, but we're thinking about 3, 4, and the tiny YOLO is like using the tiny implementation.
Why you don't try to make a comparison between all of them in performance?
Yes. So here, and then we have Nelson Chong.
Hmm.
And so we're going to be testing YOLO and Tiny YOLO on different processors and different
Mhm.
platforms, and we're going to compare some of the performance metrics, including frames per second. So we'll be doing like desktop, laptop, Raspberry Pi. And we did see that someone has ran it on Arduino, and we'll look into possibly running it on a Pico if we can.
Oh, I love to see it on Pico, by the way.
Yeah, so we found a video of someone implementing it. We don't know how if it's within our skill range for us to port it over. So we'll see how that goes. And then we'll look at the trade-offs of using tiny YOLO versus YOLO. And then with the focus on the processing rate and the accuracy. So we'll see.
Can you
if,
track the energy also?
yes, that's going to be our extension, is to track the power usage. And so that's we'll do that if we have time. So if we look at the Gantt chart, so this is our timeline. So for the first week, our plan.
It shouldn't be hard. You know why? Because you can just connect the source of power to power meter, and then the power meter connected to the board. Have you seen those like little gadget? There's like a little gadget you buy from Amazon for $20 or something like that. You connect it to your board, and then it will some of the app actually it has an app on your phone, and it will draw how much current, voltage, power continuously in a runtime is consumed while you're making process.
Okay.
So it's not really like a thing you're gonna implement. It's something to connect so you monitor while the process is running.
Okay.
Okay.
And so
Mm.
our first week, our plan is just to familiarize ourselves. So we'll test out YOLO and Tiny YOLO, just to get comfortable with using it, and then kind of to branch out. So part of our team will work on the performance metrics and the accuracy, and part of our team will work on the microcontroller side, and we'll work on that simultaneously. And then towards the end, around week 6, we will work on either adding anything to our project, or if we need to restructure and divert more time to one category or the other, we'll do that then. And then for the last couple weeks, we will work on the report, our demo, and our presentation.
Thank you. Do you guys have any question for him? I appreciate it. Thank you. Group D. Hello, we cannot hear anything. I cannot hear anything. Can you guys hear anything?
Oh, there we go.
Go ahead.
All right, so yeah, we're doing it on the RSA algorithm, and the RSA is a asymmetric cryptography algorithm,
Uh-huh.
and that means that it works on two keys, which is a public and a private key.
Uh-huh.
It's given to everyone, and this key is also kept private. And since the RSA is asymmetric, only the person with the private key can decrypt the data, even if they have the public key.
Uh-huh.
It focuses on the use of prime numbers to determine both the public and the private key.
Uh-huh.
And the strength of the encryption determines on the size of the key and the prime numbers. And if the prime numbers are low or of a lower value or size, then the private key can be deciphered, and this will cause like the data to be encrypted, which will be compromised.
Don't forget also to work on the power monitoring or energy consumption monitoring. Huh?
So, yeah. Oh,
Go ahead.
sorry. Can you? Yeah. So for this project, we're using the Nested A7 FPGA board, and we also use the Vivado to create a microplayer sub-processor. We get the speak for how long the encryption and decryption of the data text. So for example, like we put some input, and then we know for the total execution time and the key generation time. Also, we're using the user to use the input from the user to generate keys and read and decrypt data. So then finally we can obtain the results interlineation from Vivado, and then compare with the matrix from Raspberry Pi, and then we will figure out the Raspberry Pi later.
Raspberry Pi. Yeah. But why you don't try also look into RISC-V? There is actually code on GitHub for RISC-V for Nexus A7. Huh? Can you hear me?
Yeah, can you repeat one more time, Professor?
No, I said, there is actually, if you go in GitHub, there is a RISC-V software processor. You download it on Nexus A7, and then run the same algorithm on it. It's support operating system, Linux and everything. Then run it and see the numbers. Because, end of the day, what you are doing, you are comparing between microblaze, which is RISC, and ARM is RISC. So, you know what I mean?
Yeah.
Because, Raspberry Pi is also RISC. So what is the comparison here, right? You understand what I'm saying? Hello?
Yeah, we'll look into it.
Yeah, look at this and look at the power monitoring power system. Okay. As I told you, it's a gadget you buy from internet. You just connect it to the board and you will just see the whole entire power coming in front of you while you're processing data. That's actually one of the performance metrics you should look into it. And it's going to be in a practical way. Okay.
Okay, thank you, Professor.
I appreciate it. Thanks a lot. I appreciate it. Do you guys have any question for them? No questions, so I appreciate it. Thank you. Group E.
Do you see my screen, Professor?
Yes, sir.
Hi, my name is Mike Flynn, and we're Group B. This is our project. Our topic is on image processing using a Raspberry Pi. So here are some of the goals that we set for this project. First, we'll build a program on a Raspberry Pi for image processing by using OpenCV, which is a library for computer vision. And then we use that library into Python. Our second goal is we'll install a camera module into the Raspberry Pi to retrieve our images and store into the Raspberry Pi.
So we will use the images from the camera to manipulate the image. Some of the image processing techniques we'll implement are pixelation, color swapping, blurring, and some more.
Good. Can you also look into the power meter? Yes.
Hi, Professor. My name is Christian. So this is our Gantt chart here. We have a couple of due dates here that we have for our research, design, code creation, debugging, implementation, performance analysis, and finalizing the project, making any edits that need to happen. So yeah, this will all take place this semester, and I'll be completed before November 25th.
I appreciate it. Thank you. Do you guys have any question for them? No question. So thanks so much. Group F. Billy and his team. Group F. Hello.
Yeah, it is.
Go
Oh,
ahead.
sorry.
Can you hear
Do
me?
you have the presentation? Yeah, I can hear you.
Okay. All right.
Share screens. Awesome.
Okay, so we're going to be using edge detection using Pink, which is based off the Zinc processor.
Correct.
So what we're going to be doing is we're going to be testing the Jupyter framework with some of the Python APIs for Xilinx platforms. We're going to try to do some object and edge detection using mainly Canny algorithms. We'll also be studying the performance.
Hello.
I think you might have cut out there, Michael.
Raspberry Pi with OpenCV, we might have to use that data. Yep.
Okay, awesome. Yeah. So this is just our Gantt chart. For about the first month or first 5 weeks, we're going to be looking at just setting up our data sets and training the model. And then for the next month, most of the month of November, we're just going to be doing evaluation work, evaluating the performance, and making our report.
Great. You guys have any question for them? Thank you. Appreciate it. Group G, please.
Can you guys hear me?
Yes, sir.
Okay, I'm gonna share my screen. Okay, can you see my screen?
It's coming slowly. Yeah, I can see it. Yes.
Okay. So for our presentation, basically we wanted to get an OV7670 camera module working on on the microblaze software processor on the Nexus A7 FPGA. So basically the steps that we were doing is we want to display an output from that camera through the VGA port on the FPGA onto a monitor. And we want to be able to apply a filter on this VGA output using OpenCV to detect Aruco codes and display their corresponding value on the monitor, basically. So in terms of our timeline, so I wasn't sure when it was due. I specified that the end of the project would be December 5th, but I'm assuming it's before end of November.
Did you look to the syllabus?
Oh, that was my bad. I should have checked. Okay, but yeah, so we can just kind of crunch it up a little bit. So this is kind of basically our timeline. We wanted to spend some time just kind of doing research on the module, on the microblaze software processor, and give us some time, and which will kind of take up our first phase, our first task. Our second task, we wanted to focus on the camera configuration. And we wanted our third task to be basically all about OpenCV and trying to get the basic filtering working on the FPGA, and should have put on there time for a report. But yeah, so that's kind of basically our timeline.
Thank you. Do you guys have any question for them? No question for me. So thanks so much. Appreciate it.
No problem.
Group H, Noah.
I am here. Let me just share my screen.
Go ahead.
Oh my gosh, I have so many tabs open right now. Give me 1 second.
Welcome to my life, Simpson.
All right, can you see?
I see everything. Yes.
Just presenter view. Oh, all right, we good?
Perfect.
All right, so we're doing ours on SHA-3 and microblaze. So basically, our idea is we're gonna have microblaze running on multiple FPGAs, and they're gonna be communicating data, messages, or images. And we're just gonna be able to confirm that the information being sent is the information being received using SHA-3. And we have a few ways of kind of modifying that whole project, where we could either add external devices like displays and such, or we can utilize multiple different software processors on different FPGAs. And all of those would be running SHA-3. In our timeline, this is basically everything we're going to be doing. And then here's our Gantt chart for that. So we have basically the research part. We research into SHA-3, microblaze. If we decide to do other software processors, we'd research into that as well. And then we'd implement those slowly onto the FPGA and then work on communicating between the FPGAs and then all the finalization and stuff.
Do you guys have any question for them? Before, you know, the other thing I would recommend, look also on this power monitor system that I told you about.
Yeah, this is what I've been hearing the trend is from the previous ones. Yeah.
Yes.
So we'll definitely try to add something of that sort.
Yeah, fine. Any question for Noah and his team? No question. Thank you. So group I.
Yeah, I'm here.
Go ahead.
Can you see the presentation?
I see it.
Okay, so this is group I, and our project is going to be on image processing. We're going to be doing this on a Raspberry Pi, and what we want to accomplish is that we input an image and a different image would be outputted. So for example, we could do, as for an input, a grayscale image, and the output would be a color image. As for our Gantt chart, week 5 is the presentation that we're doing today. And the next 3 weeks, from week 6 to week 8, we're going to be making sure that we have the Raspberry Pi that we need and other stuff. By week 9 and week 10, we should have our first prototype. Week 11, we're going to be debugging because we're pretty sure we're not going to have it on the first try. And between week 12 and 13, we're going to be working on the video demo and IEEE format. And by week 14 is when we turn in the project on November 28th.
Okay, so that sounds good. You guys have any, you know, same thing, look at the power monitoring system. Other than that, thank you, appreciate it. Do you guys have any question for them? No question. Let's go for the group J. Clispert and his team.
Sorry, can you hear me now, Professor?
I hear you. Go ahead, Clispert.
All right, let's see. All right, can you see my screen?
I see your screen.
All right, so we're doing another project on the Fairchild Channel F, specifically a game called Hockey. This is one of, yes, yeah, this is one of the very first ROM games ever created. And we're planning on implementing this, the actual architecture for this.
I like that.
I know, it's very fun. So we were planning on creating this project because it's a little bit similar to Pong, but there's a bunch of notable differences. One of the first differences being that you actually have 2 players down here where you can see, where you can see me pointing right here. And their independent movement from the goalies, which are on the sides. And we were trying to implement that on the Nexus A7. We know that there's code out there for Pong, but because this is going to be completely different, we wanted to make sure that we can keep that completely separate from the original Pong game. But we were also planning on kind of doing the architecture for the console itself, but that may be a little bit too much as it uses an 8-bit microprocessor. It's the very first video game console that ever used it.
But you know, you can use RISC-V.
Yeah, that's what we were planning on, but we have to do some more research on that too, see if we can implement it that way too. But as you see,
there is a RISC-V processor already in GitHub. Just take it, put it on FPGA, and that's it. And then, you know, run in Linux, and then, you know, run this code.
Oh, okay. Then I'll keep that I'll keep that note on me then.
Yeah, but don't forget also the power monitor system. Yes.
Yeah, but we're gonna try to. I'll put it through BGA as well. So hopefully it works out. And then, but yeah, now that you gave us that idea, now we have a little bit less to do. So this is our plan here. We kind of extended it with the process decision or the project decision and discussion. We were debating whether we should just make the cartridge itself or the console itself, and then run it in. Then we decided to create like a charter, give ourselves a few days to do that, do some more research on this. Luckily, you just helped us right now, so we can kind of knock that off the list a bit. Then we start initiating the project, and from week 4 onwards, it'll just simply be implementation within the Nexus A7.
Okay, that's good. Not bad at all. Do you guys have any question for Clisper and his team? No, for me, I don't have any questions. Thanks so much, Clisper.
All right, you're welcome.
And I think that, we finished all of the teams. So, I want to thank all of you guys for the time. Just push a little bit hard, refine it better, and add more like into it, start working, because every other week, maybe I will ask about what is the update, because I want you guys to go and submit to the RISCA, which is the local conference on campus. And they select the top submitters to present the university on the CSU competition for research for undergraduate in with the 23 other campuses for the California State University, and we are one of those. So every year, actually, my College of Engineering, College of Science, they have 2 teams, and those 2 teams are my teams. So I won this year, same thing. I want you guys to be the winner for these 2 places. Okay, so do your best. Sounds good. regard practicing and do some examples and stuff like that, because Monday will be the first quiz, right? And hopefully on Wednesday that everything will be okay, so I can share with you some examples. We can work a little bit on the presentations and some extra material, and that's it. But at least for today, we are done for today. So if you have any question, let me know. I already recorded this, so a copy of this video will be loaded shortly into the Canvas under the module, the week 4 or 5. I will just go to week 5. Okay. Any question? Any problem? Okay, there is nothing. So it was my pleasure to meet all of you through the Zoom. Hopefully everything will be okay soon, and I'll see you in person. Thank you. Have a great day. Thank you.
Thank you, Professor.
Thank you. Thank you. Thank you. Bye-bye. God bless you guys. Bye-bye.
Thank you. Feel better.
I appreciate it. Thank you. Thank you.